Today, we're exploring the detailed process of designing and installing a helideck lighting system on a maritime vessel according to ICAO or the International Civil Aviation Organization standards. These systems are essential for safe helicopter operations, particularly during night or low visibility conditions. Helideck lighting systems are essential for illuminating the landing area, providing clear visibility for pilots. A helideck lighting system generally consists of the following: H of the helideck center, illuminated circle, helideck perimeter lights, helideck status lights, helideck floodlights, illuminated windsock, aeronautical obstruction lights. ICAO standards set the global benchmark for aviation safety, including helideck lighting systems. These standards ensure that lighting provides clear guidance and visibility for pilots during takeoff and landing, regardless of the weather or time of day. These standards are outlined in Annex 14, Volume 2, Heliports. Another set of standards is the CAP 437, issued by the UK Civil Aviation Authority, which sets out the standards for the design and installation of offshore helideck lighting systems. The CAP 437 specifically addresses the design, marking, and lighting of offshore helicopter landing areas. CAP 437 standards are primarily used by operators of offshore installations in the UK and regions influenced by UK regulations. ICAO standards, on the other hand, offer a broader framework suitable for a variety of heliport types worldwide. Engineers may also need to comply with local regulations, such as Norman 27 standards, which are the Brazilian regulations for maritime operations. In this video, we focus on the ICAO standards. The first step in the process is the planning and design phase. Engineers review ICAO standards to ensure compliance and create detailed blueprints and digital models of the helideck. Key considerations include the layout of lights, electrical schematics, and integration with existing systems on the vessel. Doing a thorough site survey of the FPSO vessel determines the optimal placement of lights. Develop a detailed layout plan that includes the positioning of all lighting components according to ICAO standards. Assess the power requirements and plan the electrical infrastructure needed to support the lighting system. Using CAD software, engineers design the helideck lighting layout, ensuring all requirements for light intensity, color, and placement are met. Next, we gather all necessary equipment and tools. This includes perimeter lights, floodlights, status lights, and control units. Ensure all lighting equipment meets ICAO specifications. Choose equipment designed to withstand harsh offshore environments, including exposure to salt water, wind, and vibrations. Opt for LED lighting solutions for their long lifespan and energy efficiency. We start with the installation of perimeter lights. These lights provide the primary visual cue for helicopter pilots. According to ICAO standards, perimeter lights should be green, evenly spaced, and visible from all approach angles. These are typically high-intensity LED lights, chosen for their energy efficiency and longevity. The lights are installed at specific intervals around the helideck to provide clear guidance for helicopter pilots during landing and takeoff. Securely mount the lighting fixtures on the helideck, ensuring they are stable and properly aligned. Install the wiring and power supply systems, following marine electrical standards to protect against corrosion and water ingress. Next, we install floodlights and status lights. Floodlights ensure the entire helideck area is well lit without causing glare. Status lights, which include heliport identification lights and obstacle lights, provide additional safety information. These lights are strategically placed and tested to ensure compliance with ICAO visibility and intensity requirements. Special attention is given to avoid glare, ensuring optimal visibility without blinding pilots. Integrating the lighting system with control units and power supply is a critical step. Set up control systems for the HSLS and other automated lighting components, allowing for easy operation from the bridge or control room. Engineers configure SCADA, supervisory control and data acquisition, systems to manage the lighting and monitor power usage. This setup allows for real-time control and troubleshooting, ensuring the lights operate reliably under all conditions. With the installation complete, we proceed to testing and calibration. Lights are tested under simulated night conditions to ensure they meet ICAO standards for intensity and coverage. This involves using photometers and other instruments to measure light output and make necessary adjustments. Calibration also includes setting up automated responses to environmental changes, such as adjusting light intensity during foggy conditions. Any necessary adjustments are made to optimize performance and ensure all systems are functioning correctly. The final step is a thorough inspection. Inspectors review the entire installation, ensuring all components meet ICAO standards and operational requirements. This includes a detailed checklist and functional testing of all lights and control systems. Once approved, the Helideck lighting system is ready for operational use. Schedule routine inspections to check for any signs of wear, damage, or corrosion. Establish maintenance protocols to clean, repair, and replace lighting components as necessary. Maintain detailed records of all inspections, maintenance activities, and any incidents related to Helideck lighting. The Helideck is now equipped with a state-of-the-art lighting system that meets the highest standards of safety and compliance. Prioritize safety in every aspect of the installation process. Consider the unique environmental challenges of offshore operations, such as high winds and saltwater exposure. And there you have it, a summary of the design and installation process for Helideck lighting systems. It is important to consult a professional as these systems keep pilots and crew safe. Thank you for watching, and if you made it this far, subscribe to our channel for monthly engineering and systems videos.